Let us solve a question on output maximization. This question was asked by a person on Telegram channel of Economics. The question is, a firm faces a production function of Q is equal to 12 k to the power 0.4 times L to the power 0.4. K and L denotes the units of capital and labor. Q is the output and can buy the inputs capital and labor at the prices of per unit of $40 and $5 respectively. That means price of capital is $40 and price of labor is $5. If it is a budget of $800, we need to find out the combinations of labor and capital he should use in order to maximize output. What we are being given? We are being given the production function is Q is equal to 12 k to the power 0.4 L to the power 0.4. Okay, also we are being given, and let me write it here, we are being given price of capital is $40, price of labor, which is wage rate, is $5, and income, total income available or total budget available is $800. Okay, we need to find out the optimal combinations of labor and capital. The question reduces to, and let's first form the production budget constraint here. So we have our constraint will be price of capital times units of capital plus price of labor times units of labor should be equal to M, which implies price of capital is 40. So our question reduces to maximize output, okay, subject to this budget constraint. That means price of capital is 40k plus 5L should be equal to 800. In place of M we have 800. So we want to maximize this output subject to this constraint. So how do we solve this kind of question? I have solved number of questions on this. Simple. There are two things, either to use the Lagrange's method or simply use the tangency condition. Let us use the tangency condition here. Okay, so actually we are being told, given this isocost line, okay, that is our budget constraint, we want to produce at highest possible level. So it will occur at a point where our isocont, this is our isocont also, where our isocont is tangent to the isocost line. We have units of labor and capital here. Okay, so we need to find the point where the isocont and isocost lines are tangent to each other, and it occurs at a point, this point is a point where marginal rate of substitution between labor and capital is equal to the ratio of the prices, that means price of labor upon price of capital. Okay, so the condition for optimal combinations of labor and capital will be that our marginal rate of substitution between labor and capital should be equal to price of labor upon price of capital. MRS is simply marginal product of labor upon marginal product of capital should be equal to price of labor upon price of capital. Now MPL means the derivative of this objective function with respect to L. That means the derivative of production function with respect to L, and symmetrically MPK means the derivative of this function with respect to K. That means del Q upon del K. It should be equal to the ratio of the prices of input factors. Okay, then we have dq upon dl. Let's take the derivative of this function with respect to L first. So we have L to the power 0.4. We are taking partial derivative, so we are interested here. Coefficient of this will become, it will become 0.4 times L to the power 0.4 minus 1 by power function rule. Okay, other things will remain same. So it will become 0.4 will become coefficient, it will get multiplied with this 12, so 0.4 into 12, it will become 4.8. 4.8 k to the power 0.4 will remain same. L to the power 0.4 will be subtracted by 1, it will become minus 0.6. Divide by, symmetrically taking derivative with respect to k, this time 0.4 will become coefficient, so 12 into 0.4 again 4.8, k to the power, it will be subtracted exponent of k here, so it will become minus 0.6. L to the power 0.4 remains same because we are taking partials. It should be equal to the ratio of the input factors. Okay, so 4.8 gets cancelled. Transposing this k to the power 0.6 to new, and let me write it here. So we will have k to the power 0.4. Transposing this, it will become k to the power 0.6. You know, when we transpose in denominator to numerator, exponent sign will get changed. Okay, and by the same way logic, let us transpose this L to denominator. Again, in the denominator, first we have L to the power 0.4, and when we transpose it, the exponent sign will get changed. We have L to the power 0.6 should be equal to PL upon PK. Price of labor is 5 upon price of capital is 40. Okay, bases are same, we can add up the exponent, so we will get 0.4.6 adds up to 1, 0.4.6 adds up to 1, so we get k upon L is equal to 5 ones are 5 eights are, so we get here 1 upon 8. Solving again, we have here L will be equal to 8k. Okay, now let's plug the value of L is equal to 8k into our constraint, budget constraint here. Okay, so we have 40k plus 5 in place of L, we have 8k is equal to 800. So we have 40k plus 5 8s are 40k is equal to 800, which is 80k is equal to 800. Dividing both sides by 80, that means k will be equal to 800 divided by 80. So we have this 8 tens are, that means the optimal level of capital required will be equal to 10 units. Okay, and to find the optimal value of labor, simply plug the value of k is equal to 10 here. Okay, that means L is equal to 8 times 10, that is L will be equal to 80. So the units of labor required uh, to produce maximum output will be equal to 80. Okay, I hope I make myself clear in this video. Thank you.